Hi, welcome back to my channel. Today I'm going to talk about IT real world problems and solutions exercise 4. So today's topic is all about multi-threading using Java 5 executor framework, how a thread can be initialized and then operated, all those things. Let's try to understand the problem. To solve this problem, I'm using Java is the language. What is a thread? Thread is a single unit of work. That means it performs some task and it's done, then its operation is completed. How to create threads in Java? In the olden days, we used to implement with two approaches. One is my thread inherits using thread class. Otherwise, you can have the other approach by implementing runnable interface. My thread implements runnable, then there is a method called run. You can go ahead and override. My thread extends thread, there also you override either this approach or that approach. After Java 8 functional interfaces has been evolved, those are also built to handle with lambda based expressions. That's very easy for us to develop. And also whenever we are making a call to any external systems, for example, say I cannot go with one by one call. Say I want to make a bunch of 10 calls or 20 calls or 30 calls. If I make sequentially and then collect the result, it will take a lot of time. Instead of that, I want to make call to parallel, collect the results, aggregate, and then build on top of that whatever we wanted to do it. So for that, you need pool of threads, right? So we will try to understand the executor framework, which was introduced in Java 5, JDK 5, that means. Before we dive into all these things, we need to understand thread lifecycle. What is a thread lifecycle? When it will be available? All those things. So in the next slide, I'm going to talk about thread lifecycle. How to create a thread pooling. As I said, a single process can be hosted as many as threads. Thread is single unit of work. Say I am running on web server application. That web server application is using and creating a lot of threads. Say 10 people making call to that application, 10 threads will be creating. How it is, that is how the server code has written. The same way we are going to implement suppose something similar to handle concurrent operations with respect to my real problem which I wanted to perform. Okay. So in Java 5, they introduced executor framework. It has a broader set of APIs and classes introduced, and generics they introduced. There are a lot of type collections also introduced. You can read those. I'm not going to talk about Java 5. So executors are executor interface, executor service interface, scheduled executor service, thread pool executor, like different varieties of framework utilities they built it, where we can go ahead and use and build it. In this particular exercise, I'm going to use fixed thread pool, where I'm defining 5 threads, iterations 20. I want to make 20 times call to external system. I need to collect it. Call a subroutine operation, assumption this is external REST API. Example output, list of future 20 results. I am going to collect it and then I wanted to print it on the console. That's the motivation. Now try to understand the life cycle of a thread. Whenever my thread T equal to new thread, if I say that is a new state or born state, that means just born the thread. Once it is there, the status as a born state, then T dot start you apply. T dot start you apply, then what happens? It will not immediately start running. Okay, it never runs. it first verifies is this hardware, is that process where it is running that thread has sufficient resources. So until that, it moves to runnable state. That means it is not going to perform anything. If it is resources available, then immediately it starts the position from runnable to running. And if we have any of this performed, for example, blocked thread dot sleep, that means I'm blocking for some milliseconds, and once that millisecond elapsed, it resumes automatically. No, if I'm writing code wait, thread dot wait, okay, then it will wait. You need to notify by another call to resume that thread from lock to release. Likewise, you have waiting on the some milliseconds. You can also wait and notify so that it will be released. Likewise, you have the different blockings of thread. Once your task has been successfully completed, no more being used that thread. That thread will be automatically killed, or it goes to terminated status. That is how the life cycle of a thread works. The prerequisites: core Java, not JDK 14, but in my case I'm using Java 18.4. Okay, IntelliJ is my workbench and other things. This is intended to work with the Java developers who have experience. This is where you can download Java and set it up. Now let's dive into the real hand. So today, as I said, I'm going to solve problem number 4, thread pool based execution operation. I got this kind of a problem statement requirement, how I am going to build the logic. This is all I'm going with assumption. I say that thread pool app. Okay, so I'm going to define main. So here I'm going to define how many threads I wanted. 5 threads as per my PPT, PowerPoint, I mean to say, and iterations. I would say iterations equal to say 20. 20 times I want to make a call to external REST API. So I pass 5 threads, iterations, then I make a call. For example, okay, suppose. So here what I'm going to do is I'm going to handle the things. So I say for how many iterations, whatever the number which I set it. Now I make a call using executor. How I am going to create executor framework? You can see it very easy. Executor start new. You can see variety of ways: fixed thread pool, cached thread pool, single thread pool executor, and so forth. I'm going to choose fixed thread pool. I say n threads. That will give me the service, executor service. So what I'm going to do, I use the executor service dot submit. As I said, we can implement with two different approaches, either runnable or callable. So callable is where you can get the result from where did you call the external API. Runnable, you will not get any results. So that is the two different. I'm going to use callable. So as I said, I'm going to use Java Java 8 functional interface concept. Call REST API. REST API what I'm going to do is I'm going to pass something what thread is running this operation. I want to check that. Okay, so this is what I'm going to perform. So that means there is a small operation. I am going to build that with this syntax. String name, name for meaningful purpose. I specify private static string return. Ideally here you make call to external in this exercise. Okay, real call to external API. In this case I am not doing that. Okay, so I'm just returning the name of the thread which is giving it to me. So this is very useful call from result, I would say. So now I'm going to get all this collection of results. So I need to handle it with a list, right? Without that I cannot able to hold it the results. So I'm creating a list object which can hold the results. Result list equal to new array list. So what I'm going to do here, result list dot add result. So this is a very easy lambda expression according to Java 8 interface. Here I really make external API call and get the result that I return. In this case I am just passing the name of the thread which is going to perform this operation, for example. Now I got the results. So what I supposed to do is return that result to my main driver, result list. Here I have called, so I'm going to collect the results. Then what I want to do, features dot string dot for each I wanted to print it. So let me try to, this will throw two types of errors which I supposed to handle it. So here I'm going to get the result, actual result, whichever the name of the thread which is being thrown. I'm just printing a console level result thread name. Thread name, I'm going to get it, whatever it is. So this is very simple and easy code. I'm just doing a return. For example, here you really make call, but this is how executor framework you use it and make a call and run it. Let's test this application. Are we going to get all the results or not? We can see that. Now you can see that 5 threads created initially, and then second thread took the in charge, and third thread likewise it started and processing. So here we supposed to do few things, fixes, then the code will be clean. Executor service start, shut down. We have to do this. If we do not do this, there will be a problem. Make sure is terminated. This is the call which is being used to perform all the tasks are properly completed. All tasks completed, successful checkpoint. As soon as you made call, then shut down the executor service so that the resources will be freed up as soon as we are done with it. So make sure executor service that shut down, and then this will evaluate all the tasks because it dispatches parallelly, completed or not. We need to validate. If it's all completed, then false, that time it comes out. If it is true, then it will be keep running. If it is false, then comes out. So all the tasks which say here 5 tasks likewise, whatever it is. Without this, your code will get into error prone. Please make sure that. Okay, see, you can see that my thread is not closed. It's supposed to automatically close it, but it didn't because I did not execute this statement. That's the reason. This time I'm going to rerun. You see the real effect. The process will automatically terminate it. See, now this process is terminated. It was not hanging. So make sure you shut down the executor service and all tasks are being completed. Now you can see initially 5 threads when the iteration started, and then fourth thread only sufficient to fulfill. That's the reason we can see that fourth thread performed most of other tasks. So this is how you have to ensure writing the best code whenever you are developing any type of application. That's all for the demonstration session. Please like it, share it, comment it, and subscribe it. This will give you immense understanding of how people are taking it, my videos. Thank you. I hope I come up with new videos. Until then, stay tuned.